Hello there, ROS developers, and welcome to the live class number 88. Today we are going to be talking about ROS subscribers. So, if you are interested, stay with me. We are starting. Let's go! Alright, so hello everybody. We are here one day more in live class number 88. Thank you very much for being here with us. We are going, as I've just said, to talk today about ROS subscribers. So we are going to try to do an hour about ROS subscribers so that you can really understand how they work and what are they for. So that's what we are going to do today. First of all, let me verify that everything is working fine, that you can see properly the stream, you can hear me without problems. So I can see here, hello, many people, Marcus, Mikael, Derek, Gerson, Martin, hello everybody, welcome. So please let me know if everything is fine. I can see Gloria as well. Check. Okay, so the sound is perfect. Okay, excellent. Yes, so it seems that everything is going properly, so let's go for it. Then, first thing, as always, I'm going to share with you guys here the link for today's project. So let me share it right now here in the chat. Let's go for it. There we go. Alright, so there you have the link for today's project, and then, as always, I'm going to switch now to my computer screen. So, yeah, let's go for it. Alright, then, as always, you need to come to the ROS Development Studio here. If you already have an account, excellent. If not, just create it. It's completely free. And then, once you are logged in the ROS Development Studio, and you click or paste the link here in the URL, whatever you prefer, then you are going to have here this project available in your workspace here in my project, which is the ROS Developers Live Class number 88. Yep. Then, as always, all you have to do is to click here in the open button and open project, and this is going to start opening the project. So mine, it's already loading, and meanwhile it starts loading, let me also comment to you a couple of things. So first of all, I want you to remember, I don't know if probably some of you are already there, but maybe we have new people who doesn't know about it. So here we have the ROS study group here at the right bottom of the page, and if you click here, this is going to take you to our Discord server. This is growing each day. We are already more than 430 people, more than 40 online right now. So basically here in our Discord server, what you are going to find is a big community of people who is interested in learning ROS, who is interested in developing with ROS, is creating projects, whatever, but they have the same interest as you. So you are going to find many people here that have the same interest than you, and that is interested in ROS and in learning ROS and working with ROS. So here you can make questions, share your projects, whatever you want. So here you have our Discord server by clicking here in the ROS study group. Then another thing I want you to show to you is the ROS Developers Day that we are going to have in June 27th here. So it's quite soon, Then this is the third year that we are going to organize this Developers Day, let's say. In the previous years it was a Developers Weekend because It was done in 2 days, in Saturday and Sunday. However, this year we decided to make it into one single day and put all the activities there. And basically, we are going to have many ROS experts which are going to do presentations explaining different ROS topics. And the thing which is our characteristic is that these conferences are going to be practice focused. Yeah, so it's not about just listening to one people talk, but you are going to listen while you work on the project. Yes, in ROS Development Studio. So as I am doing right now, every speaker is going to share with you a ROS project, and meanwhile he explains during his conference, you are going to be able to practice with him the whatever the topic is. Yep. So this is going to be very soon. So if you are interested in joining it, come here to this page. Let me share it with you as well in YouTube. There we go. All right. Excellent. Then my project is here already loaded. So I'm going to open here. Yeah. So here I have my notebook for live class number 88. Yeah. So for this class, you should have at least a couple of requirements, which are Linux basics and Python basics. Yes, these are our online free courses. You can check them here by clicking on the link. Yeah, where you are going to be able to learn some basic concepts of Linux and also basic concepts of Python programming, but focused to robotics. Yeah, oriented to robotics. Then here in our Robot Ignite Academy, you are going to find these 2 free courses right here. Yeah, so you are going to need this knowledge in order to properly be able to follow this live class, and in fact most of the live classes. Yeah, because always you are going to need a minimum knowledge of Linux and Python. Yeah, so I highly recommend you to do these courses. And also, if you complete these 2 courses, let me tell you that you have the possibility to do this exam here. No, it's not this one. It's here, yeah, in the prerequisites path. You have the chance to take here the prerequisites exam, which is going to allow you, if you pass it, to get a certificate. Yep. So yeah, highly recommendable to do these courses. And as I've said, today we are going to be talking about ROS subscribers, and we are going to be using the RB-Kairos robot. This one here from Robotics, from our colleagues from Robotics. Yeah. Then, in order to start the simulation, you have the instructions here. So you are going to need to come here to the simulations menu, click on the choose launch file button, and then here you are going to have a list of lots of launch files available, because this is a quite huge simulation. Yeah. Then from all these lists, you need to search for the RB-Kairos _sim _bring up package. Let me look for it. Here we have it, RB-Kairos sim bring up _new. Yeah, and from here you are going to select the RB-Kairos _complete.launch. Yeah, you have these package and launch file names specified here in the notebook. Then click on the launch button, and this is going to automatically start the gazebo simulation here. Yep, this is going to start loading here. Let me put it here at the right side. Then here the package name, remember it's new. Yeah, it has a new at the end, RB-Kairos sim bring up new. And the launch file name is RB-Kairos _complete.launch. Yep. Then this is going to start a simulation like this one with RB-Kairos in an indoor environment here. Here we are, it's loading the simulation. Let me come here. So here you have the robot, which is super cool. In fact, in the master we did a couple of months ago, the live master we did about mobile manipulators, we were using this robot in its real version, of course the simulated version, but we had the chance to work with it as well, to work with the real robot in order to test everything we did during the master, and it was a really cool experience. All right, so here I have my simulation loaded with the RB-Kairos here in this indoor environment. So at this point, I'm set up to start the class, but I want you to confirm me to confirm to me that you are in the same spot as I am. So you have the ROSject loaded with the notebook here at one side and the gazebo simulation here at the other. Yeah. So let me know please in the chat that you are all in the same point as I am, because as I always say, I want you to practice with me. Yeah. So I don't want you to just sit there listening and watching what I'm doing, but I want you to be practicing and doing everything with me. Yep. All right. So let me have a quick look here at the chat. Can you please put the name of the launch file in the chat? Yeah. Okay. Okay. Yeah. Yeah. So it's in the notebook, Jeff. You can check it in the notebook as Sandy told you. So you can find it here. Simulation loading. Yes, loaded and ready, said Sujay. Alright, so I'm going to take a chance here to drink from my super fancy ROS Developers cup, as always. Delicious. Alright, so let's go back to work. Simulation loading. Okay, so it looks like everything is loading here, loaded. I can see here Amen, who says that everything has loaded properly. Excellent, so let's go for it. Don't you think so? All right, so finally understand ROS subscribers. Okay, so ROS subscribers is one of the most important elements, yes, in ROS, because ROS, the ROS ecosystem, it's based in sharing data, yes? So sharing data is one of the most powerful things that ROS has, because it allows to be independent from the hardware you are using, yes? So ROS at the end doesn't care about the hardware, but it cares about data, about messages, yes? Then you can think of this environment. I created this image here, which I hope is going to help you understand more in a visual way how this works. So basically, this is the ROS ecosystem. Let's say we would have a ROS master here, which is controlling everything. But basically, ROS is based in topics. Yeah, this is a topic, and you can think of a topic as a pipe, as an empty pipe, where you can either put information or extract information from it. Yeah, we're not actually extract, but read it. Yes, because the data will keep being there. But you can think as a topic here. As you can see, I have done a very simple drawing here of a pipe. Yeah, but you can think of a topic as an empty pipe. Yes, then into this pipe, you can either put information or read the information which is going through this pipe. Yes? Then who does this? Well, ROS nodes. Yeah, ROS nodes are the ones who can either place information into the topic or read, subscribe to the information of this topic. Yeah? So this will be the general idea, and this is super powerful because this allows ROS to don't have to care too much about the hardware. Yeah, so if you have a program in ROS which works for one robot, it's going to be very easy to move it to another robot. Yes, because at the end all you have to match are topic names, messages, which is the data, and etc. Yeah, so this is one of the most powerful things in ROS, and one of the things that have made ROS the robotics standard. Yeah, then today we are going to focus on the subscriber node. Yeah, in the next live class, which is going to be next Tuesday, we are going to see the publisher side. Yes, but now we are going to focus in the subscribers. So in the ROS nodes that subscribe to the data which is flowing through this topic. Yeah, subscribe, read this data, and do whatever with this data. Yep. Then let me have a quick look at the chat before. RB-Kairos, yeah, I see you guys are still asking about the launch file, so let me remember here. Yeah, you have it here. So here you have the data from the package RB-Kairos sim bring up underscore new. Yeah, remember this, it's sim RB-Kairos sim bring up new. You have to select the launch file RB-Kairos complete. Yeah, you have it here in the setup the environment section here, how to launch the simulation. Yeah, here you have the data in order to start this gazebo simulation, and you are going to have something like this. Yep. Then, so any question about this part? Let me know, guys. Did you understand more or less what I have tried to explain here and show here with this graphic? Yeah, is it clear? Do you have any question on this thing so that I can keep moving? Or if not, I can try to explain it a little bit better, or... That topic thing, is it like Kafka? Well, I don't get what you mean, Ayman. I don't get what you mean. Everything loaded and ready to subscribe. Got it. Yes, got it. Okay, excellent. So Ayman, I didn't really understood your question. So if you can try to rephrase it or something. Okay, got it. It's fine. Got it. It's clear. Okay, excellent. So I'm going to keep moving, but I will keep coming back here to the chat to see if you have any questions, yeah? Then, first of all, let me open a new shell because I'm starting to work with shells here with the command line tools, yeah? Then, first of all, some data about topics, yes? So in order to work with topics from the shell, in ROS, you use the rostopic command, yeah? Rostopic, like this. You can do a rostopic H in order to get information about all the possible topics, or all the possible commands, yeah, that you can use from rostopic. However, this is one of the most basic ones, which is the rostopic list, yeah? As you can see here, rostopic list is going to list active topics. So by executing this command, I'm going to get a list with all the current topics, yeah, these pipes that we have here, all the current topics that are right now active, yeah? So as you can see here, we have many of them, yeah? Then, in order to get information about a specific topic of all this list, we can use the rostopic info command, yeah? So, for instance, let's say that I want to know more information about the TF here topic, for instance. Then I would do a rostopic info and the name of the topic, yeah? So rostopic info TF. Then this is going to give me information about this topic. So which information? Well, the message, the type of message, the type of data that it has, that it contains, yeah? So this topic, which kind of data contains? In this case, it contains a data which is called TF message, yeah? Then I can see here information about the publishers. So which ROS nodes, yeah, remember? So which ROS nodes are publishing into this TF topic? So we have here two nodes, Robotics Publisher and Gazebo, which are currently publishing data into this TF topic. And also I get information about the subscribers. So which ROS node is reading information from this topic, yeah? So as you can see, for a single topic, you can have different publishers and different subscribers as well, yep? Then, what else? Yes, then with this we can get information about the topic, yeah? So some information like, as I've said, the type of data, which nodes are publishing into this topic, which nodes are subscribed to this topic, but you can't actually see the data, yeah? So you can see the type of data which is published, but you cannot see actually the data which is flowing inside this topic, yeah? For that, we need to use the rostopic echo command here, yeah? So for instance, I can do now a rostopic echo of the TF topic, and now I'm going to be able to actually see the data. Yeah, so now you can see here, let me stop this for one moment. So now I can see here the data, yeah? So this is actually the data which is flowing through this topic, yeah? You can see here the different messages, and these messages are from the type TF message, the one we saw with the rostopic info, yeah? So let me run this one more time, because there's another thing I want to explain here. So I'm going to open here another shell, and now I'm going to run again the rostopic info topic command for the TF topic, yeah? So rostopic info TF. So now what can I see here? Now I can see the Robotics state publisher here and gazebo, which we already had before. I can see this laser scan multi-merger, but I can see another subscriber. So now I have two subscribers. And which is the other subscriber? What is the subscriber that has appeared here? Well, this subscriber, it's me. It's me who right now I'm subscribing to this topic. Yes, so here I have executed a command, which is the rostopic echo, which has allowed me to subscribe to that topic. So right now I am a subscriber of this topic, yes? So that's why I appear here. Yeah? So let me close this. Sorry, let me click here the dismiss button. Yeah? So actually, by using the rostopic echo command, what you are doing is to generate a subscriber of a topic from the command line tools. Yeah? So now I have stopped my command. So if I do a rostopic info again, as you can see, this second subscriber has disappeared. Yeah, because I have stopped the command, so I am no longer a subscriber of this topic. Yes, I'm no longer reading the information, the data which is being published into this topic. Yeah, so far so good. So the first way of creating a subscriber of a topic, it's by the command line tool using the rostopic echo command. Yep. However, this has some limitations, yeah? Because using the rostopic echo command, I can, in fact, indeed, subscribe to a topic, but I cannot do anything with this data, yeah? So I can only visualize it. As you have seen, by executing this command, all I can do is to visualize this data. But I can't do nothing with this data, yeah? So I can only visualize it. That's why most of the times you are going to use this rostopic echo in order to debug problems, yeah? So if you are having some kind of problem in your simulation, you are probably going to need to execute this rostopic echo command to see data flows, to see what data is published into a topic, to verify if this data is correct, is the expected one or not, etc. Yeah. So the rostopic echo command at the end is going to be mostly used for debugging problem. Yeah. But however, when developing projects, you are going to most of the time need to create a subscriber in code. Yes. Why? Because by creating a program, a subscriber program, you are going to be able to get the data, but you are going to be able to process it, yes, to analyze this data and do something with this data, yes? So this is the difference, and this is the limitation of the rostopic echo command, yeah? So, next step, how do you create a subscriber using code? Well, you have different options. You can create it, for instance, in C++, in Python. In this case, we are going to do it in Python, using Python code, yeah? So the first thing we are going to do now is to create a new ROS package where we are going to place all the code. So let's come here and execute these commands we have here. So we are going to come to the catkin workspace src folder, and we are going to execute this command here, catkin create package, subscribers, and we are going to add rospy as a dependency, yes, because we are going to be working with Python. There we go. So now, if I open the IDE, let me do it here real quick. I'm going to open the IDE. Now I'm going to be able here to visualize in a graphical way my workspaces and the files I create in them. And here, inside the Catking workspace, I'm going to find, let me open this. There we go. Inside the SRC folder, I'm going to find this new subscribers package which has been created. Yeah, currently it's empty, but you are going to find the package here. Yes, which has been created using this command. Then, here what we are going to do, first of all, is to generate a code for a super and very simple subscriber. Yes? Then, let's come here to the SRC folder and create a new file. And I'm going to call it simple subscriber.py. There we go. And then I'm going to grab the code I have here, going to select it, copy it, and paste it into my program here. Yes? Alright, so here I have generated a subscriber, but in code. Yeah, so remember, doing the rostopic echo command here, we created a subscriber from the command line tools. Yeah? So now I am creating, with this code here, a subscriber, but using Python code in this case. Yes? Then what does this code mean? Well, let's analyze it. It's very simple, as you can see, very few lines. So first of all, here I am importing the rospy module. Why? Well, because I'm going to need it. Yes, I'm going to need this rospy module because I'm going to be working with Python for ROS. Yes? Then let's jump for a moment this callback function here. Yeah? Then here we have the rospy init node. Here we are creating a ROS node. Yeah? So we are generating a new ROS node. Yeah? Remember this graphic we had here with the topic, the ROS nodes. Yeah? Then here in this line, the rospy init node, what I am doing is to create one of these elements, a ROS node. Yes? Then in the next line, here I'm saying, hey, this ROS node is going to be a subscriber, or it's going to have a subscriber. Yes? Because a ROS node can have multiple subscribers and can have also multiple publishers. Yes? But in this case, I am saying, hey, inside this ROS node, I'm going to generate one subscriber. Yeah, you have this in this line here, rospy.subscriber. Then this subscriber is going to subscribe to the topic with this name. In this case, it's a_topic. Yes? So this subscriber is going to subscribe to a topic. Yeah? All right. Then what else do I need to specify here? I specify the topic name, and I specify also the type of message which this topic is going to contain. Yeah? So what kind of messages do I expect to get from this topic? Well, in this case, I expect to get integers. Yes? Which is this int32 message. Yes? This means that it's expecting integers, integer numbers. Yeah? By the way, I'm seeing here an error in the code. So all of you, please do this one thing that I'm going to do. So in order to be able to use this int32 message, I need to import it, yeah? So I'm going to need here to come at the imports at the beginning and do an import of the this int32 element. Yeah, there we go, import int32. But I need to specify the package as well. So from standard messages dot message import int32. Yeah, so here I'm saying, hey, from this ROS package import this type of message. Yes, by the way, let me copy this line in the chat in case you want to just copy paste it. I'm going to place it here in the chat. Yeah, so this line, basically what it's doing is to import this type of message so that I can use it here. Yes? Then let's go back to a subscriber. So I define which topic I want to subscribe to, which type of message I am expecting on this topic, and finally I define a callback function. yeah? This callback function is going to be triggered every time a new message is published into this topic. So every time a message comes to this topic, so every time a publisher publishes a new message into this topic, this callback function here is going to be triggered, activated. Yes? Then here I have the definition of this callback function. Basically, this callback function is going to get the message, and in my case, I'm just going to print it. Yep. So super simple. And then at the end, I place a spin here, which we are going to see later exactly what this is, because it's very important for subscribers. Yeah, this spin, it's super important for subscribers. Yeah, but basically for now, just remember that this is going to keep here the program active. Yeah, it's not going to end the program, but it's going to keep it active, alive here, so that the subscriber doesn't die. Yep. Then let me test this super fast. So first of all, what am I going to do? I'm going to come here to the Catkin workspace, SRC folder. I am already there. Great. CD subscribers. I'm going to access the SRC folder of the subscribers package, and here I'm going to see that my simple subscriber Python script doesn't have execution permissions. You can see this here. So as you can see, it has read and write and read permission, so it doesn't have execution permission. So I'm going to add here execution permissions to this file so that I can execute it properly. Yes, and now we are going to see it in green, and now it has execution permissions. All right, then right now what I'm going to do is to run this program. So ROS run subscribers and simple subscribers. There we go. So now I have my subscriber running. Yes? So now, if I come here, well, and I do a rostopic list, I'm going to see one thing. I'm going to see here at the top of the list that a new topic has appeared here, which is named A topic. Yes? So if I get information about this topic, A topic, what am I going to get? I'm going to get the type that this topic uses. It uses integers, as you can see here. Then it has no publisher, no one, no ROS node is publishing into this topic, and I have one subscriber, which is this simple subscriber node. Yes, this simple subscriber node is the only one which is subscribed to this topic. Yeah. However, as you can see, no one is publishing here. So right now, this print, it's not printing nothing because this topic is empty. Yeah. So there's no data in this topic. So I am not getting any data. So I cannot print any data here. Yes, this callback cannot be activated. And I cannot print any message. Yep. So, sorry. I don't know. There we go. Yep. So, what should I do now? Okay, what I can do is to manually print from the command line tools, for instance, a message. So, I'm going to do a rostopic pop into the A topic, which uses standard messages integers here, yeah? And if I do a double tap here, it's going to auto-generate the structure, and I'm going to be able to fill here the data. Yeah, so for instance, I can put here 100. Yeah, so basically with this rostopic pub command, what I am doing is to generate a publisher. Yes? But however, this we are going to, as I've said at the beginning, we are going to review publishers in next live class, so I'm not going to talk too much about them today, but basically here, this is the same as a rostopic echo, but for a publisher, yeah? So here we are generating a publisher. For this topic, we are going to publish this type of message, and we are going to send this data. Yes? Then if I execute this command, now, as you can see here, from the shell with the subscriber, this data, which is the 100 that I published, this data appears here. Yes, so now my callback function has been triggered, so I am executing this line, this print, and I am printing the message. Yes? Another thing I could do, for instance, is instead of publishing only one message, I can publish this message at a rate and keep publishing this message. For instance, like this, I'm going to start publishing this message continuously at a rate of 1 Hz, in this case, into this topic. So my callback function keeps getting triggered each time a new message enters, as you can see here. Yeah? Alright. So far so good. So we have seen the basic code here of a subscriber and the basic behavior here of a subscriber. Yes? And now, next thing is that we are going to go a little bit deeper into getting data from a topic. Yeah? However, let me have a quick look at the chat to see if how you guys are doing, if you have any question. Let me check here. Let me see. Okay, can I have several subscribers in one Python file? Yes, you can, Helder. We are going to test it in a moment. But yes, so you can have several subscribers in one Python file. Is it possible to subscribe only for one message? Well, not by default, Diego. So when you subscribe for a topic and for all the messages which are being published into that topic. However, you can create some kind of mechanism that when the first message enters here, you close the subscriber. Yeah, so you can do that. But by default, here, you are going to subscribe to the topic and to all the messages which are published into this topic, yes? Then later you can create here in the callback some kind of control code that whenever the first message enters, it closes, yes? It goes outside the callback and it closes the program, etc. Yeah? All right. Yeah, a possible way would be to use spin once. Yeah, that's Shish Warrior. It's suggesting the spin once thing. So as you can see here, in the let's talk about this right now. So here we have the rostopic spin. Yeah. So basically, what it's doing is to keep constantly calling this spin once function. Yes. This spin, it's constantly calling spin once many times. Yes, in an endless loop until somebody terminates this program. Yeah, so until somebody terminates this program, this spin here is going to keep executing this spin once method. Yes, then each time an spin once method is executed, the callback here is triggered. Yep. Then by only using one spin once, you are going to subscribe only to one message. Yeah. I don't know if maybe for some of you this is a little bit complicated. I don't know. Yeah, so I can see here she's another very good comment. The callback is used to do any processing of the data. He's just printing it as a simple example. The ROS spin command keeps the node alive basically. Yeah, so as I've just said, here inside this spin, what it's doing is to keep doing calls to this spin once. And each time a call to the spin once method is performed, the callback function is triggered. Then the callback function, as you can see here, what it's doing is to receive the message, which is published into the topic, yes? Then, with this message here inside the callback, I can do whatever I want, yeah? So later we are going to create a program which does something with this data, yeah? This is a super simple example, but later we are going to evaluate, analyze this data, yeah? Then, as I've said, basically this spin is what is keeping the program alive, yes? If I remove this spin, well, let's do it later. So let's move to this one, because this is a super simple example, yeah. And just to make a brief introduction to how to program a subscriber in ROS. However, here we are going to start doing something more useful, yeah. So here we are going to do two things. So first of all, we are going to subscribe, because here we subscribe to an empty topic, yes? So this topic doesn't exist in the simulation, yeah? If I do a rostopic list now, we are going to see that this topic does not exist, yeah? Here we don't have this topic. It doesn't exist, yes? So basically, by creating this subscriber, I am also creating this topic, yeah? However, this is not usual, yes? So most of the time you are going to want to subscribe to a topic which already exists in order to get data, yes? Because you are interested in that data, yeah? So for instance, here we are going to create a program which is going to subscribe to the odometry topic in order to get the pose of the robot, yeah? To get what is the position and orientation of the robot at each moment, yeah? So let's create a new program here, and we are going to call it getData.py. Yep. Then here, let me copy and paste this code here. There we go. Excellent. Yeah. So what am I doing here? Okay. So as you can see, the code is a little bit different. Why? Because here I have placed it into a Python class. Yes? So this is a very simple structure and a linear way of doing it. Yeah. However, working with Python classes, it's what you are going to do most of the time if you work with Python. Yes? Then here I have basically switched from this basic structure to a Python class. Yeah? So here I am defining the class, which is going to be named getData. Here I have the constructor of the class, where I'm defining the subscriber here. And here I have the callback function, yes, which is going to do whatever with the data. And here I have the main, yes. So as you can see, here I am initiating the node, the ROS node. Here I am generating an object of this class. And here I have the spin, which is going to keep the program alive, yes, so that my callbacks can be called, yes? Then, once I create an object of my class, the first thing that is going to happen is that my constructor is going to be called, so the subscriber is going to be called. Then this subscriber is going to subscribe to this topic, robot/robotic base control/odom, which uses messages of the type odometry, yes, which we are importing right here. And this subscriber has this callback associated, which I have defined right here. Then this callback is going to get the message, as you can see here, and it's going to print here a log with the current pose of the robot. Yes? We have it here. Then let's execute this. One moment. Right here. So, ROS run subscribers and get data. All right, it's not going to detect my program. Why? Because I haven't assigned execution permissions to it. So let me do it right now. Chmod +x to the getData.py script. And now, yes, now ROS run subscribers get data. There we go. So now what is going to happen here? Now I'm going to start getting the position and orientation, so the pose of the robot, as you can see here. Yes? So this is the same, let's say, as doing a rostopic echo to this command, right? To this Robotic base control ODOM command. So let me come here and grab this name, and I'm going to do a rostopic echo directly here to this command, to this topic, sorry, and let's see what happens. I start getting data as well. However, as you can see, the data, it's not the same, yes? So let me come back here. So here I have much more data than when I created the program, yes? Why? Well, very simple, because here I'm getting the wall odometry message, yes? So by doing the rostopic echo, I am getting the full odometry message, which has many information here. As you can see, it has a header, it has a pose, it has a twist, yeah? So it has many information here. And here I'm reading the entire odometry message, yeah? However, as you can see here, in the code, I am not printing the entire odometry message. So the entire odometry message here, it's assigned to this MSG variable, yes? This MSG variable contains the wall odometry message. However, here, as you can see, I am not printing the wall odometry message, but I am accessing here a couple of variables, yes? And what are these variables? Well, if we get the structure here of the odometry message, ROS message show odometry, this is going to give me the structure of the odometry message, yes? And as you can see here, the odometry messages has many messages inside it, so yeah, so it's a complex, a composite message, which has many messages inside it. Then, in my code, what I am doing is to access from the wall message, here, I have access the pose variable, which is, which one? This one, yes? Here we have the pose variable, yes? Then this pose variable is associated to this message. So this pose variable contains all this message, yes? With the pose, position, orientation, and covariance, yeah? However, I'm not stopping here. I am accessing yet another pose variable, yes? So not the first one, but I am now accessing this one, this pose, the second one. So now I am restricting my message to this second pose, which is this. Yes, it's the position and orientation, but without the covariance, because as you can see, the covariance is at the same level of this pose message. Yes, you can see it here on the indentation. Yeah? So basically I am accessing from the wall odometry message, I access one pose and two pose. So at the end, what I am accessing is this message here with the position and orientation. Yeah, you can see it here, message, pose, pose. Yes? Then here with the rostopic echo, what I am doing is to get all this structure with the header, everything. Yes? So with the rostopic echo, I'm getting the full odometry message, which is why I get so much data. On the other side, by running my program, I am only accessing that pose variable that I just showed to you. Yes? That's why here you can see that I have much less data. I only have here the position, as you can see, X, Y, Z, and the orientation in quaternions here. Yes? So now, what I am doing is to accessing a real topic, which, by the way, we can do as well a rostopic info here, rostopic info of this topic, and I'm going to see that it uses the odometry type of message, and it has no subscriber now because I'm not running my program, and it has one publisher, one node. There is one node which is publishing data into this topic, which is why when I subscribe, I am able to see this data, yeah? So now, for instance, if I run my program one more time, it's subscribers. Okay, let me source my workspace. There we go, ROS run, subscribers, and get data. Here I'm going to run my program, my subscriber program. And now, if I run again the rostopic info topic, as you can imagine, this subscriber, my program, is appearing here as a subscriber, yes? All right, so you have just seen here an example of more complex, let's say complex, because this is not really complex, yes? But we have placed the subscriber into a Python class first, and we are now subscribing to real data, yes? We are subscribing to a real topic, which actually contains useful information, yes? In this case, it contains the pose of the robot, so I can know where the robot is. In this case, as you can see, it's in the 0, 0, 0 position because the robot is at the center. It hasn't moved at all. Yeah? Yeah, do you understand this? Let me have a quick look at the chat one more time. Let me see. But if I have a lot of subscribers in one class and I want to spin all of them but with particular conditions, I want to receive and proceed the message from a specific topic only once. So you want to subscribe to topics but only get one message. No, it's that, Yehor. I understand. The error, package subscribers not found. Getting error. I missed it. Okay, if you get this error where it doesn't find the package, guys, try to do as I have done here, the source command, source of the Catkin workspace, devel, and setup.bash, yeah? Execute this command to source your workspace. In case you are getting that error, let me copy it here at the... Here you have the source command, yeah? In case you have any problem that you are not finding the ROS package or something like that, as I have seen, please execute this command. Please repeat the ROS run command. I missed it. ROS run? No, the ROS run command, it's ROS run, the name of the package here, and the name of the program, which in this case I am executing get data.py, yes? So it's ROS run, the name of the package that contains that you have created, yeah, the name of the package, which is subscribers, and the name of the program you want to execute. In this case, we are executing the get data.py, yeah? All right, so let's keep going. So for instance, what happens if I now remove this spin here? Yes? So I'm going to remove this spin here. What do you think it's going to happen? Let's try. So now I'm going to do a ROS run again. Subscribers, get data.py. Let's execute it without the spin. And nothing happens. Yes? So as you can see, if I remove the spin and execute the program, nothing happens. I cannot read any message. Why? Because the callback function is never called. Yeah? So I generate the subscriber, but here, after generating the subscriber, what I am doing is to terminate my program, so my callback is never called. Yes? So as you can see, this is the huge importance of the spin. if you remove the spin here, the callback, your callback is not going to be ever called. Yes? Then, for instance, we had here, in fact, I never tried this, but let me do it one moment, with the spin once instead of the spin. Oh, we don't have the spin once function here in rostopic. It's not called spin once, or spin once rostopic. Yeah, because the spin once function is for oh yeah, okay. Yeah, so I'm going to share this with you if you want, because the spin once, it's only for C++, yes? However, as you can see in Python, it's not usable, these spin once. Alright, so I'm going to share with you, for Yuhor, who was asking this, I'm going to share this, because you have the option here to use the, the wait for message here function instead. Yes, because this one I do know it, and I know it works. So I'm going to share this with you, in case you want to use it. Yehor it was, I think. Yeah. However, I'm not going to show it right now, because I would have to modify the code and everything. Anyways, if you want to know more, Yehor, if you are interested in knowing more, just contact me, yes, and I will help you. Yeah. However, let's keep going here, and let's try to finish here the class. So remember, guys, you need to place always the spin. Yes, if you don't have the spin, the callbacks of your subscriber are not going to be ever called, as you have just seen right now. Yes, then finally we have another program here. Yes, in this case we are going to call it process data. Yes, because this here we are getting data from a topic. Yes, however, most of the times this is not going to be enough. Most of the times you are going to want to get the data and analyze this data. Yes, do something with this data. This is the most common case. So let's create here a new Python script, which we are going to call process data.py. There we go, process data.py. Then let me come here and grab the code. Let me copy it and paste it here. Yeah, so let's quickly analyze this code now. And here we have the imports. In this case, we are importing the laser scan message, which is the data type that laser uses. Yes, so this gives you a hint of what we are going to be doing here. Yeah. Then here we have the class, the Python class, which is called process data. Here we have the constructor, where we are defining a subscriber which is going to subscribe to this robot front laser scan topic. Yes, so this is the topic where the front laser is publishing its data. Yes, then we specify here the type of message, and we specify as always a callback function for this subscriber. Yep. Then inside this callback function, what I am doing is to receive the laser data into this message variable. Yes, then from this message I am getting a specific data. Yes, which is the data that it's telling me what is the laser reading right in front of the robot. Yes, if you want to understand better this, I suggest you to have a look at some of the videos we have explaining this, how to analyze laser data. I think we also have some live class. Yes, however, basically this what we are doing is to get the laser value which corresponds to the front of the robot. Yes, so this is the front of the robot, and the laser value which corresponds to the front of the robot, we can get it here from the laser, from the ranges, from the beam 210 specifically. Yes, then basically we are saving this data into a variable here which is called forward laser, yes? Then next we are printing this value, this laser value, we are printing it to the shell, and then here we are calling another function which is called process data, which is a function that we have created and defined it here, yeah? So here we have this function, process data. Then here we are doing, what are we doing? We are evaluating this forward laser variable, yes? Then if the value is higher than 1, I'm going to print a message saying keep going, yes? But if the forward laser variable contains a value lower than 1, I'm going to print a message which says, caution, you are getting close to an obstacle, yes? Then this number here corresponds to meters, yes? So basically here I am saying, hey, if the forward laser is not detecting any obstacle closer than 1 meter, just keep going. But if this forward laser is detecting an obstacle which is closer, less than 1 meter, I'm going to print a message to have caution, yeah? So be careful because the robot is getting close to an obstacle, closer than 1 meter, yes? So basically what I'm doing here is to process the data, yeah? So I am processing the data I am getting here in my subscriber, in my callback function, I am processing it and doing something with this data in order to decide some behavior for the robot, yes? Then, for instance, real quick here, let me run this program. First of all, let me assign execution permissions, and let me run these subscribers. Process data, there we go. Yes, so this is going to start now printing. Keep going. As you can see, here we have the laser value, which is 7.2, 7.3 more or less meters, and I'm getting the message keep going. But now, let me do one thing. I'm going to start moving the robot forward here towards this wall. Yeah, so I'm going to start moving the robot closer to this wall to see what happens. So let me execute this command, ROS launch, RB-Kairos, gazebo, new, keyboard teleop, which is going to allow me to control the robot, and here I'm going to start moving the robot forward. So let me do it here real quick. And let me place this down here to visualize it better. So here we can perfectly see the message. And now I'm going to start moving the robot forward. As you can see here in the simulation, I'm moving the robot forward. And as you can see, the value here in the laser is starting to decrease. So now it's 5.6 meters, yeah? Each time I move the robot a little bit more, this value keeps decreasing, yeah? 5.5, 5.2, 4 meters, yeah? I keep going. For now, the message is keep going, yes? But I'm getting closer to 1 meter each time. I'm at 2.8, a little bit more, 1.4, 1.3, and there we go. So now the laser reading has gone below 1. It's 0.7, as you can see. And now the message I'm getting here, it's, hey, caution, you are getting close to an obstacle, yes? So here you can see an example of a subscriber which is getting data from a topic, and it's evaluating this data and doing something with this data. Yeah, depending on this data, it's doing something here. Yep. All right. So yeah, I think that's all, guys, for today's class. We are already past the time. So yeah, in fact, we have been able to finish the notebook, so I'm very happy. Then Great, so let me have a quick look at the chat to see if we have any questions. I can see here. Thanks, Alberto. It was quite clear. Thank you. All set. Thank you for your time and shared knowledge of ROS. Thank you. ROS is useless. Why do you say that, Sarthak? ROS is not useless. ROS is the most powerful tool in order to make robots useful. Yeah? Thank you, says Yegor. Lauren, thank you for your time. You're welcome. So my pleasure. I hope that from this class you have been able to grasp some concepts and to have a better idea and to better understand ROS subscribers and how ROS subscribers work. Remember, guys, that today we've been talking and discussing about subscribers, and the next class is going to be about publishers. Yeah, so they are going to be highly connected between them. So I highly recommend you to come to next Tuesday's live class as well. I will be waiting for you there as well. I can see many messages now. Thank you. Great class. Just want to know if you would be doing a class on subscriber multiple topics at different rates. Well, we can program it. I mean, that's a suggestion. Rahul, I suggest you to write a comment in this video, not here in the chat, but in the fixed comments. So when this video is uploaded, publish a comment and tell us, hey, actually, I would like to have a class about this. Yes, because all these comments, then we get them and we save them for deciding what are going to be our future live classes. Yes, so please send us a comment, put it here in the video, for instance, and we are going to take it into account for future live classes. Would love to join again next week for the publisher class. Have a great week, Alberto and team. Thank you very much, Sujay. Thank you very much. Have a great week, you too. Thanks, Albert. This was very clear and helpful. Looking forward. Okay, excellent. So I'm very happy that you enjoyed the class. I enjoyed doing it as well. And well, I will see you next week, next Tuesday, for the publishers class. Until then, guys, remember, stay safe, stay home. Yeah, you need to stay safe. And very, very soon we are going to be over this situation, which is not nice to anybody. However, we need to keep fighting. And thankfully, we have ROS, which can help us to be more focused during this time home. Yeah, doing things, working with things, and learning, for instance, ROS. So yeah, okay, I'm going to shut up and I'm going to leave it here. Okay, thank you very much, guys. Bye bye.